Hey there, this is the latest video of my deep dive series where I look at some of the mods that I'm using in my games, and I hope you may find that these are worth a look for use in your own games. If you have any suggestions for future deep dives, please add a comment to this video, and if you just want to say howdy, well, add a comment for that too. However, before I get going, I want to point out that these videos will be directed from the point of view of PC users using a keyboard and mouse and otherwise running with the default settings. Mostly because that's what I have and I'm pretty set in my ways. Therefore, if you are running on some other platform or are directly connected to your machine through a neural interface, or even if you just use a good old-fashioned gamepad on the PC, some of the control options and elements will undoubtedly be different, but the functionality demonstrated should still be valid. And so this time I'm going to explore the CMDCam mod, version 2.0.15 for Minecraft Java Edition version 1.19.2. I wanted to talk about this one as there are very few camera mods like this for Forge, and the learning curve on this one is kind of high. However, it is the camera mod I use for all my own videos, and I highly recommend it for other folks making Minecraft videos. This is because CMDCam is all about cameras. No, not those. I mean the camera in Minecraft. No, not the camera in the Education Edition. No, and not the camera from any other mods. I mean this one. The screen that the player sees during their time in the Minecraft world is the camera. And in vanilla Minecraft, the camera has 3 modes. The default is the first-person perspective, and using F5, the player can switch between this view and 2 third-person views. One focus on the player's avatar from the front, and one focus on the player's avatar from the back. But if you're trying to make a Minecraft video, you'll find that your options for filming epic cinematic-style footage using the vanilla camera are somewhat limited, in the same way that vegetarian options are somewhat limited at a steakhouse. The footage will be jerky to some degree, and depending on what you want to capture, you may have to become skilled at controlling your avatar without actually seeing where they're headed, and to do so smoothly. And then there are the retakes, and there are always retakes. You'll have to try and do it all over again, and again, and again, and all exactly the same way. So yeah, it's a piece of cake. In the same way that trying to repair the engine in your car while driving down the freeway is a piece of cake. Well, that might be a bit of an exaggeration, but you get the picture. And that's where CMDCam comes in and shines. CMDCam starts with this concept of the vanilla camera, and then it adds functionality from there. The first of which is the ability to lay paths that the camera will consistently and predictably follow exactly the same way each and every single time. Setting paths is almost as easy as falling off a log. The easiest way is to move your avatar where you want to set a point and hit the P key. You can do the same thing through the command line. And in fact, if you do use the command line, you don't even have to move your avatar. You can actually enter a complete set of 3D coordinates, so it's possible to enter the entire path without moving your avatar anywhere. And once you have your path defined, you can start your animation, which is when the camera will move down the chosen path. You can kick off the animation using the U key or the command line. And that is the absolute most basic of the basics of the mod. However, as folks who have dealt with the termite infestation have learned the hard way, there is a whole lot more under the surface. For one thing, there's a bit of complexity when it comes to executing a path. Now, if you've set up a path as I have done already, you can use a command to show your path with a visual representation. The path is shown with the chosen interpolation. In this case, interpolation is a method of figuring out the exact path between the chosen points. Different interpolations result in slightly different paths, and different paths produce different results when you run them. Now, it's best to see this by example. So in this case, I've chosen the linear interpolation, which is really no real interpolation at all. The camera will simply follow from point to point in a straight line and then immediately adjust to follow straight to the next point. While this is simple and very easy to comprehend, the results can feel a little bit primitive and abrupt. Another interpolation option is Hermite, As you can see here, the mod uses the points on the path as markers and then computes a smooth and flowing path between the points. Now this results in a much smoother and flowing run, and for most cases this is probably the best option, which is probably why it's the default choice. A relative of Hermite interpolation is cubic interpolation. And the basic idea is similar to Hermite in that it tries to create a smoother and flowing result, but the key difference is that as the camera lines up to pass through a defined point, it does so such that it passes through that point in a short but straight line. Now when you compare it to a Hermite path, you can see that while in that straight line, the camera often drifts further away from the defined path, and when the algorithm goes back to smoothly bringing the camera back onto the defined path, the result is often larger and longer sweeping curves. All of that can seem kind of convoluted, but it can lead to some very compelling video as well. However, there's another interpolation worth playing around with. The cosine interpolation will show a path that is directly point to point as we saw with linear interpolation. And in fact, it executes the same path and results in the same view, but the difference between the linear and cosine interpolations is one of speed. If you set a path of 2 points using linear interpolation and then start the animation, it will run between those 2 points at a constant speed. However, if you run the same path using the cosine interpolation, the speed will vary. It will start slow and slowly gain speed toward the middle of the path and then slow back down toward the end of the path. Now, to me personally, the results feel a lot like an amusement park ride, where you pull out of the station slowly, build up speed, and then slow down again when it's time to get off the ride. And finally, there's one more interpolation option to talk about, but before I can, you will need to understand the concept of targets and how they're used. Now, simply put, the target is what the camera is aimed at, so as the camera proceeds down the defined path, it will always point directly at the target, even as the path weaves and winds in various directions, including away from the target. So targets come in two flavors, and these are my made-up terms, but they help me in keeping things straight. I think of targets in terms of direct or indirect. Direct targets are pretty easy to understand. Using the command line, a target can be any position in space via coordinates, or a particular block, or a specific entity, or another player's avatar, or even the current player's avatar. That part's pretty clear. What is less clear is setting the target to none. The camera is no longer focused on a single point or thing, and this means that the target is indirect. And what I mean by that is that you can then change your camera's direction as much as you want as the camera proceeds down the path. This is achieved by the facing of your avatar when you set a new point on the path. In other words, when you execute the path, it will move from point to point, but it will also swivel as needed so that when the camera reaches a given point on the defined path, it will be pointed directly at whatever the avatar was looking at when the point was added to the path. And this can be a very powerful feature. Now that we've introduced targets, we can briefly return to the concept of paths and talk about the last interpolation type, which is circular. With a direct target chosen and the interpolation set to circular, just define a path with a single point and then start the camera. The path will automatically resolve to a circle from the single path point, and it will orbit around the defined target. Now the circle is on the horizontal plane at the same relative distance to the target as the original path, but you can see why you must have a direct target for this to work. If the target is set to none, then the camera will start and stay at the single defined point, looking at whatever the avatar was looking at when the point was defined. And yes, this can still be very useful, but it's a bit of a corner case. An interesting thing to note is that once you set up a circular interpolation around a direct target and start the animation, the target might possibly get up and start moving around, and if they do, the circular path will move with the target, keeping the same relative distance as when the target was standing still and daydreaming. So far, we've covered how to set up a path, how paths are interpolated, and how to set, or not set, targets. So to kick off the real magic, one must start the animation. Now this can be done through the keyboard using the U key, but by default it will run through the whole path in 10 seconds. Using the command line though, you have the option of setting the duration to pretty much anything you want, almost literally. The duration can be defined in milliseconds, seconds, minutes, hours, and even days, and those are actual days, not Minecraft days. Now you can also set a flag to loop through the path a given number of times or to loop through the path indefinitely. A very important concept to keep in mind is that when the camera is in default mode, the player's avatar is literally the camera. In other words, if you set a path and then kick off the animation, you will see the camera follow the path. But if there was another player in the world at the same time, they would see the first player's avatar floating down the path, and except for the ability to pass through solid objects, that floating player acting as a camera is very much an active part of the world. Which is to say that if, for example, such a player was flying down a path that happened to go through a contrived pen filled with hostile mobs, said player would almost certainly be attacked by, and probably killed by, those same beasties. And even after death, the avatar would continue to float down the path until the animation was complete. Another consequence of running in default mode is that you cannot open a command line and stop the animation. So, in the case I just described, if the player suddenly realized they were headed into a metaphorical car wash of death, they couldn't do anything about it. The animation would run its course, the player would probably have to respawn afterwards, and then run back and recover their corpse. However, there is a way around this, and that's to use outside mode. When the player runs on the same path in outside mode, the camera still follows the defined path, but this time it's a virtual camera, while the player's actual avatar is still standing wherever they were when they kicked off the animation. Now, nothing is attracted to or hostile to the flying virtual camera in this case, and as an added bonus, the player can enter the command line at any time to do anything they would normally do in the command line, including, and perhaps especially, stopping the animation. Now, except for very specific cases, I always like to run my cameras in outside mode. Two of the more advanced features are zoom and rotation. They do pretty much what you think they do, but maybe not exactly in how you think they would. And if you think back on what I told you about paths, you may remember that if there's no direct target selected, the camera will point at whatever the avatar was looking at. Now, zoom and rotation kind of work the same way, but they work whether there is or is not a target selected. For example, I set a point on the path and then move to where I want to set the next point. But I use the zoom function to really close in on the target, and then I add that second point to the path. The zoom is now part of the path. And then I move to where I want to add a third point, and I restore the zoom back to the default level, and then add the third point to the path. Then I run it. As the camera moves from the first point to the second point, the camera will naturally and smoothly zoom in so that when it reaches the second point, the zoom is wherever it was set when the point was defined. And as the camera continues to the third point, the zoom adjusts back to the default setting because that's where we set it for the third point. Rotating the camera works in exactly the same way. If you are playing and running CMDCam on a single player world, then your paths and settings will persist for the session, and that is the session of Minecraft and not the world. So you can exit your world, go into another world, exit that world, and return to the first world, and your settings will persist as long as you kept Minecraft running the whole time. However, if you leave the world and close Minecraft and then restart it, you will find that when you return to that world, the CMDCam settings are cleared and restored back to default. On the other hand, if you play on a server, you can save most of your settings and data and even restore them, which makes the use of servers very convenient for setting up and running complex scenes and choreography. Here are some tips and tricks to keep in mind. Pressing the U key will kick off the animation with a default duration of 10 seconds. Now, if you press the U key after having previously kicked off the animation using the command line, The U key will start the animation with the same duration as what was set in the command line. So, if you use the command line to start a 5-minute animation, pressing the U key after that will also start the animation with a 5-minute duration. Likewise, if you use the command line to start the animation with a new duration, say 30 seconds, then the U key will subsequently kick off the animation with a 30-second duration. When placing points on the path in creative mode, it's a breeze to just launch your avatar into flying mode and then fly directly where you want each point on the path to be. However, if you're in survival mode, you can't do that. But you can simulate that with a bit of time, effort, and scaffolding. Just raise the scaffolding to each of the midair path points you want to set, then climb the scaffolding and set the point. Of course, remove all the scaffolding afterwards, especially if it will show up in the end result. Or, if you're really good with working spatial coordinates in your head, or even on paper, you can use the command line to set up your midair path. Now, I've already told you that I almost always work in outside mode. However, one of the times that I definitely want to stay in default mode instead of outside mode is when I want the path to be very long. And by very long, I mean that I want it to extend beyond my defined render distance. If you activate outside mode and then set up a very long path and then leave your avatar at the end of the path when you start the animation, you will find that the animation will begin and your screen will be filled with only sky. No terrain, no mobs, no nothing. However, as the animation proceeds and the camera approaches the edge of the render radius, the world will begin to appear, and once the camera is completely within the render radius, things will proceed normally. If you do the same thing while in default mode, the camera is actually stuck to the avatar, and therefore the avatar is actually where the camera is located. And since rendering the world is based on a set distance around the actual avatar, the world will be rendered and visible in real time just as if the player was standing there, because technically they are. There's a caution to be made here. If you want to craft a cool video where the camera zooms quickly across a wide expanse of terrain, just remember that your poor machine will need to render those chunks in real time. And so a video zooming across a bunch of open ocean may not be so bad, but zooming across a wide plain into a really mountainous and heavily forested region with bunches of structures, that might turn out less than optimal. In these cases, it might be better to run the animation longer and therefore slower, and then speed it up in post-production. Another trick to use is the pan. Panning is basically scanning the horizon. Now, the way to achieve this is to focus on a distant point on the horizon and set your first point in the path. Then, without moving, turn to where you want the pan to end with your focus still level with the horizon and set the second point. Then run the animation. The camera remains in the same spot, but simply turns from the focus of the first point to the focus of the second point. The longer you set the duration of the animation, the slower the pan will proceed. Also, if you want to pan across more than 180 degrees, you'll need to use 3 points on the path. You need one at each end of the pan, and you will need to have one set in between those two. That's because the mod will turn in the direction where the second point is closest to the first, and for a pan of over 180 degrees, that would actually mean that the camera is facing the exact opposite direction. So setting that second point between the other two will give the mod a closer point to turn to, and from there the final point will continue to be the closest on the current arc. So the pan should continue to the desired completion. If you want to make a full 360 degree pan, all you have to do is set the target using coordinates or by tagging a block in the spot you want to target and then removing the block, as the targeting remains locked where the block was. After that, set a path point 1 or 2 blocks away and set interpolation to circular and then run the animation. Again, a longer animation duration will result in a slower pan. When running CMDCam with other mods, especially cosmetic mods, there may be unanticipated results. For example, when I run an animation and I have items from the Immersive Paintings mod in the frame, some of those items will come out looking much more pixelated during the animation than if I was just looking directly at them in game. Another example is the storage drawers mod, where I sometimes will not see the items rendered on the front of the drawers, and this is usually because I'm running an outside mode, and so my avatar is probably outside of the render range for those items, and so the camera sees blank faces on the drawers as it makes a pass. There are several more command line options that I didn't cover here, and you can get slightly more details on them from the CMDCam page on CurseForge than you can in-game. I didn't cover them here because 1, I don't use them, and 2, I don't use them because I haven't figured out how they work yet. However, this is a very powerful mod, and I strongly encourage you to just set up a world with this mod in it and play around with it. You'd be surprised at what you can do or create with it. And of course, I also encourage you to reach out to the mod author and let them know that you appreciate the hard work they put into their mod, and please thank and compliment them on their willingness to share with the modding community. There's a lot of great modded content out there, including this one, and they are on a par with commercial software, and it's made available to us for the incredibly low price of $0. So to get any cheaper, the mod author would have to pay you. So I would say that this is a screaming value for what we paid for it. So until next time, I hope this finds you and yours in good health, good spirits, and perhaps a touch of good fortune. Cheers.